Alright, if you're watching this video, it's because you were absent when we started the intro to waves, so make sure read over the PowerPoint and make the foldable. Let's go. A series of seismic waves hits Tokyo. A seismometer records 5 strong quakes in 1800 seconds. The source of the waves was found to originate 125 kilometers away from the city. The first of these waves reached the city 5 hours after leaving the source. What is the frequency of the seismic waves? Well, frequency is number of oscillations over time. We have actually two time values here. The number of oscillations per time. So the time it takes between each of the waves hitting the city. Let's draw a picture. Here we have Tokyo. And then out here is the source of the waves. And these waves, they're going to leave the source. 2, 3, 4, 5. And they're going to hit Tokyo. They leave the source. It takes them 5 hours to travel this distance. But Tokyo experiences these 5 waves in succession. It takes 1800 seconds. So the time value we're actually going to use is the 1800 seconds. It's the number of waves that actually hit Tokyo per unit time. Number of oscillations there are 5. And each one hit Tokyo in 1800 seconds. So 5 over 1800, let me grab my wabbit. It's good to see some calculator practice. Remember, go alpha y equals and enter. So 5 over 1800. That's 1 over 360. And I want that number in decimal form. 2.7 e negative 3, or 2.77. I'm going to round to 2.8. E negative 3 seconds to the negative 1 power, which is the same unit as a hertz. The period, it's easy, period equals 1 over the frequency. So 1 divided by 2.8 e negative 3, or I can raise this to the negative 1 power, or 2.8 e negative 3 raised to the negative 1. I grab the wabbit. Here it is. I can see that it was 1 over 360, which should just be 360, but I'll confirm 1 over 360 raised to the negative 1 gives me a period of, 360. 360 seconds. So the period means that between each of the oscillations that hits Tokyo, between each of the rocking events, 360 seconds apart. That's what the period indicates. And what is the wave speed? Well, wave speed is how fast a wave travels from a source, and it's also equal to the wavelength times the frequency. I don't have the wavelength. No wavelength. But I do know how fast or how far the waves traveled per unit time. So we will have to use velocity is equal to, speed is equal to distance over time. Because I don't have the wavelength, but I know how fast these waves were coming in. So we have 125 kilometers in 5 hours. From Tokyo to the source, 125 kilometers, and it took 5 hours for the first of the waves to reach Tokyo. And I'm just going to leave it in kilometers per hour. So I'm going to do 125 kilometers over 5 hours. And that is 25 kilometers per hour. km per h. Okay. Next, practice. A glacier slides into a bay, creating a series of water waves. The first of these waves hits the bay shore 45 seconds later. The distance to the shore is 157 meters. The distance between the wave crests is 1.5 meters. What is the wave speed? So again, I have the wavelength, and I know that the waves hit the bay shore in 45 seconds, or at least the first of them. I just don't know how much time elapsed between each wave. All I have right now is the shore, and I have the source of the waves, and I know that the waves spread and hit the shore in 45 seconds. But I just don't know how much time elapses between each wave crest hitting the shore. So I don't have the period. The distance between the wave crests is lambda, and the entire distance between the source and the shore is 157 meters. So I can still get the wave speed, even though I don't have frequency, I don't have period. I know that the wave speed is still the distance traveled by the first of the wave sets, the first of the waves divided by time, 157 meters in 45 seconds. That's 157 over 45. That gives us 3.5 meters per second. What is the frequency? Well, now I know that what the wave speed is, and I know that wave speed, in addition to distance over time, it is also lambda times frequency. Wavelength times frequency is also the wave speed. So I can get frequency now. V over lambda will give us frequency, 3.5 meters per second. Lambda is 1.5. This gives us a value of 2.3 hertz, or 2.3 seconds to the negative 1. Box these in. Finally, what is the period of these waves? Period is equal to 1 over frequency. 1 over 2.3 hertz is 0.43 seconds. And again, that means if you're standing on the shore and the waves are hitting you, they would hit you every 0.43 seconds. I hope you found this video helpful. Thanks for watching. Steady well.